昨天有做梦，看少人了。昨天做梦，Simon
干 intelligent application 的 motivation report，有点像写那个的写那种 research paper 的那个 introduction。
几时交？
昨天5点，中午，下午5点。然后今天30号是 AI assignment 读的 deadline，那个也很难。哎，一句话，你8点就是延追了，没有办法讲说。
明白，我明白。
去过新的图书馆，
去啊，去啊，去啊！怎么？
就这样。
好啊，好啊，那会整多。
跟你在 Australia 比，不能比哦。
没有，我们是三个比较小的图书馆
那种装修程度诶，
啊，
装修程度，
中学生
对，装修。
这比较美吧？我们那边很旧了，有图书馆，就是
这样多有
可是我们的那个床比较大，我们床可以摇嘛，
啊！我看到那书很少，
就这样矮的，但是也还没有满啊，现在。
不是，听说不是讲上次讲办公室需要搬去那边，真的吗
是那种 admin
？Administration 啊，
HR 那些校长，
其实你搬去，我到校长还在 B1 嘛，然后那边空间你不能有大厅耶，
好像那边全部要给学生做活动的，
哇，找到来哦，而且找到来哦，来做活动啊！
做活动啊，
你看那天我带你打球啊，
然后
你半夜2点太迟了，我要睡觉了。诶，这老师带我
那种是几点？
2点半啊，
那天是拜几？
2点半啊，拜六还拜四，那小优这个，
拜五，拜五晚上我在做。
幸好你不是我讨厌老师啊，不然你更死。2点半就带我，你那时候就
那你知道没
有？
有？你们 fix 你们先答案，然后我来我就来，
最后来不及，做完了啊，做完，
对吧？
最后可能知道我做完了啊，
不够人，
一是不够人，二是我功课太多，做不完。
是那个。诶，可以找你们班那几个
可以，
公平他们，
最多啊，
先找他们，我可以来就来。那天拜五晚上有做梦哦，我知道了，我去写生的那个 CS 那边，然后弄到很迟。
可没，你第一次被打啊？我的，
想讲什么？有一个垃圾啊，比赛，
参加到我的位置，
记写生嘛，他都叫了，了不起，
有要捧场的，
不然等下很难呢。
很少人呢。
呀，会 midterm 嘛？
啊，
你外分都有 class assignment 的啊，assignment 的哦。好诶，later midterm need to book give back or not? Okay, so later we discuss midterm in the third. Later.
没有啊，人家红叶跟来知道，有几个比他们多。又要天，完了兄弟，完了。我也是操作这种心态，然后他又讲应该不多少还不是我没有挂我自己做公司的，他妈的。
Okay, maybe let's start. Let's not wait. So I haven't posted out the latest lecture not yet because I was caught up by a lot of things recently. Yeah. Okay. 来。Okay. 出发。
你刚刚在短。我操，写这个字。结束。
Okay, so let's go through again what we have done before. Okay, last time we learned how to find domain of a function, right? But we didn't really talk about the range yet. Okay, so let's recall what's domain first, and then we discuss how to find the range. Okay, so what's this function here? Right, this function takes in two values. Okay, so going from R2 to R. Okay, if you put two X and Y number in, you will create another single number. Okay, so it's R. So how you imagine this? Remember how to imagine this surface here? Where does this graph lies in? This graph lies in R3. Because you take the domain plus the codomain, R2 plus R. So you get R3. Okay, so this graph should live in R3. So it's X, Y, and then Z. Okay. Okay, so what's the natural domain for this function here? Any restriction by this function? Huh? Any restriction on the function? What's the restriction of square root function? Must be positive. Okay. So the thing inside the square root function must be positive. So 9 minus x squared minus y squared have to be greater or equal to 0. Okay. Which means xy have to satisfy x squared plus y squared is less than or equal to 9. Okay. So what's x squared plus y squared less than or equal to 9? What shape is this? Circle with radius 3. Okay. But we want everything that's less than 9 also, right? Okay. So you need to fill the circle. Okay. All the radius within 3 we also accept. 3, 2, 1. Okay. 0.5. Everything we accept. So this is what we call this. This is what we call this. So everything inside. Okay. How about the range? What's the definition of range? Zero to 3. Wow, so fast. So what's the range? Range meaning is where the f gets sent to. Okay. So range are the point are such that fx equals y for some x. Okay. Okay. So how to determine the range? Okay. So range is determined by where you send all the code, the things inside your domain, right? Okay. So, but we have control on our domain, right? Okay. What's our domain? Our domain satisfies x squared plus y squared less than equal to 9. Okay. So this equation here, right? Observe that this equation here, okay, also have another bound, which is greater or equal to 0. Okay. Is it? Can you guys see why? Because you are taking a positive of 2, taking sum of 2 positive numbers. Okay, it's always greater than 0. When does it equal 0? When x and y are just 0. Okay, not cool enough. Okay, so so to check the range, right? Okay, try to manipulate this inequality here to get something related to your function. Okay, so in your function, right? What do you need? You need minus x squared minus y squared. Okay, and then 9 plus minus x squared minus y squared, and then take square root. Okay, there are a few things to do here. But here is x squared plus y squared, right? How do you make it into minus x squared minus y squared? Huh? You can just multiply negative to the whole inequalities. Okay. So in this case, you get minus 9 less than equal to minus x squared. Okay. So what can you do next? You can add 9 to the whole inequalities. So when you multiply negative, right, you swap the inequalities. Okay, that's why this number swap, right? Because if 2 less than or equal to 3, it is not that minus 2 less than or equal to minus 3, but minus 3 is less than or equal to minus 2. So when you multiply negative, the inequality swap. Okay, is it clear? So let me just put something here. Okay. So next, so you add 9 to all of them. Okay. So you get 0 is less than or equal to 9 plus minus x squared minus y squared less than or equal to 9. Okay. So in the last step, you just apply square root on all of them. Okay. So when you do this operation, right, you are not doing in a chain. Actually, you're doing on two inequality, just that I write them at once. Okay. So when I say 0 less than equal to x squared plus y squared less than equal to 9, it really means two statements here. Okay, there are two statements here. This means that 0 is less than equal to x squared plus y squared, and x squared plus y squared is less than equal. Okay, so you are actually doing two calculations here. So we just keep performing two calculations here. And at the same time, they can be combined. So that's why we write like this. Okay. So really, you are doing to both of them, both inequalities. Make sense? Okay. Okay. So our range is in between 0 and 3. Okay. So our range is in between 0 and 3. So maybe you can hit this picture here. Let's say we don't know what's the shape, right? We don't know what's the shape, but we know that the range is going from 0 to 3. Okay, so somewhere around here, above this circle. Okay. Right. So you could imagine a 3D shape now. Okay, but we're not sure what is it, right? So to determine the shape, right? What's the method we can try? What's the method we can try? What's the method we can try? K, what's K? The height. What's the word? What's the word? The level surface. Okay, so we can look at the level surface. We can use a plane to cut our surface and then see what's the shape at every level. Okay, so let's recall what's level surface. Or the level curve. So curve is a lower dimensional, so surface is higher dimensional. Later we'll see. So we can let our function equals to some constant number. Okay, and then we look at the pre-image, the value of k. Okay. So we fix our height and then see what's the shape. Okay. So let's fix some height here. So what's the range of my height in this case? What kind of number you can pick as a height? Okay, only 0 and 3, right? Because the range of f only reach until 3. So if you pick 4, what do you get? You get nothing. Okay, the pre-image is empty. There's nothing. Okay, so we can pick some number, for example, 0, 1, 2, 3. Okay, in between 0 and 3. So for these number, right, what do you get? Can you anticipate what do you get? What do you get? Anyone see what you will get? A bunch of circles. Okay, a bunch of circles with different radius. Okay, so can you see the circle is increasing in radius or decreasing in radius when you go up in height? Huh? Decreasing? When you go up in height. When the height increase, the radius increase or decrease? Huh? Increase or decrease the radius? 9850. So the radius decrease. Right. The number getting smaller, right? This is the radius. So when you go up in height, okay, when the height increases, the radius decrease. Okay. So when you got to the highest point 3, the radius, the circle become just a point. Yeah, because only 0, 0 satisfies this equation here. Right? Because you need to add 2 positive number, non-negative number, and only 0 will satisfy this equation. Okay. So what do you get? So you get circle with radius 9, circles with radius 8, 5, and then 1 point. Okay. So if I don't want to draw it here, I can draw it in another place. Okay. Another place here. So you can see that we set the height to be, so let's put K here. 3, 2, 1, 0. Okay. So 0, we have a bigger radius, smaller radius, even smaller, and then up to 1 point. Okay. So if you will check, because this is continuous, so you can check all the points in the middle. And you can see that the radius also decrease radially. Okay. So if you add infinitely many circles, then they will kind of join out together. Actually, it's not corner. This drawing is a bit chap. So it actually is a hemisphere. Okay. Okay. So domain, range, and then how to see the level surface, level curve. Let's go on. So you can see that here. So there are some example of contour here. For example, the first one for fxy equals to minus xy times e to the power minus x squared minus y squared. Okay. But you can see that here there's no k here, right? Didn't tell you what height are they. Okay. You are not given the height. Okay. But you are drawn with this graph here. Okay. So you can see that in the opposite of first quadrant and third quadrant, actually the height is increasing when you go into the circle. Okay, when you go inward, it's increasing, but for the other two, it's decreasing. Okay. Okay. So you cannot just determine from this level curve here without the height. Okay, you need to be taught by the height so that you know what's going on to this circle here. Okay. The next one looks a bit like the spider. So this level curve is a minus 3y over x squared plus y squared plus 1. Okay. So you can see that there are two decreasing circle, right? Two decreasing circle. So whether or not it's going up or down, I need to tell you the height. Okay. But the actual graph is drawn on the right hand side. Okay. Yeah, these are just examples. So similarly, we can do it for more variable, 3 variable, 4 variable, 5 variable, 6 variable. Okay. So 3 variables still make sense because we still can draw the level surface, but we can't really draw the actual graph because if it is 3 variable, what's the graph? Where the graphs have to live in? You are going from R3 to R. Okay, so where the graph you need to plot? R4. Okay, who can imagine R4? Yeah. So if you can really evolve this world because the problem now is we can't imagine R4. Okay, although we are living in an R4. Okay, so in this case here, what's the natural domain for this function ln z minus y plus xy sine z? Does this function have restriction to the domain? What happened? So loan function, any restriction on loan function? Okay, so you need to take things that is greater than 0. So let's put down what's our restriction is. So we need to have z minus y is greater than 0. Okay, because non-negative, there's no value. Any restriction on sign or not? Sign. No, right? Okay, sign takes in any values and then split out number in between 1 and -1. Okay, and then xy, you can really just put anything. So it doesn't matter. Okay, so there's only one restriction here. This is your natural domain. Okay. Okay, so similarly, we can also talk about level surface. So just now we talked about level curve, right? Because just now we have smaller dimension. When we go to higher dimension, it becomes surface. And above surface, we just call it surface. So given a function of 3 variables, okay, the surface, when we set the function to be equal to some constant, okay, is called a level surface. So now we take a plane in R3 to intersect our surface, okay. So for example, find the level surface of the function below. Okay. So when we want to find level surface, right, we need to let it equal to some k. So where does this k live in? This k here, what? Huh? What? Okay, so this k here, you see, f of xyz equals to k. So this k is lie inside the range of f. Okay. So what's the range of f in this case? So the range of f is in turn determined by the domain, right? Okay. Okay. So what's the natural domain for this function here? Okay, so the thing inside the square root have to be greater or equals to 0. Okay, anything than that we can set. Okay, which means what? This is the natural domain. So what's the range? What's the range? So what's the bound on f? Huh? So you just take square root of this inequality here. You can see that f is everything greater or equal to 0. Okay, so this is the range. So let me put down what we are doing here. So here is the natural domain. Here is the range. Okay. So now we want to find level surfaces, right? Okay. So we can try few numbers that is greater or equal to 0 and then see we can find any pattern or not. Okay. Can you give some numbers that you want to try? 1. Okay, how about start with 0 and then 1? What else you want to try? 2. Yes, 100. Okay, that's the number in my mind. Okay, let's try k equals to 100. Sorry, I'm too so high a bit. Okay, k equals 0. Okay, so let fxy equals let fxyz equals k. Okay. So for the first one, you get s squared plus y squared plus z squared equals to 0. And then second, square root s squared plus y squared plus z squared equals to 1. And then square root s squared plus y squared plus z squared equals to 2. And then the next one is square root x squared plus y squared plus z squared equals to 100. Okay, so what are these? What are these? Sum of squares of a variable equals to some number. What are these? Huh? These are a high dimensional circle, which are sphere. Okay. If you still remember the stuff from conic section or the quadratic surface. So now is the time to help you to identify these surfaces. Okay. So similarly, these 0, 1, 4, 100 square are the radius of your sphere. Okay. So you can see that when the height increase, right? So this height is the height inside R4. Okay. When the height increases, the what? The sphere also increase in size. So I cannot draw the R4 for you already. Okay, we can only draw something inside our domain. So inside our domain here is R3. Okay, the whole R3 become our domain. We need to take point inside R3 and then input to this function and then output. Okay, you don't think that R3 is already very high. So in your AI, right, you need a lot of data, right? More than 3-dimensional, maybe 100-dimensional. Okay, you input it and then just give you a number. Okay, right? Okay, so you don't think that R3 is already very high. So you sometimes in reality you need more. Okay, more data, more variables. Okay. Okay, so you get these bunch of sphere together, increasing in radius. So far, okay. Level surface. Okay. Anyone know why we are drawing sphere but we call it a surface? No. Yeah, it's a R2 dimensional. Wait, 2-dimensional surface inside R3. So this sphere, right, is not field, it's not solid. Okay, it's just outside. Okay. If you walk on the sphere, right, you just feel like 2-dimensional. You are just walking on a 2D thing. Okay. Hey, just listen. Listen. Want to try a few more examples? Are you guys continue? Are you guys comfortable with finding level surface or want to try a few more? Few more. Okay. So how about this one? Okay. So this is fxyz equals to z minus x squared minus y squared. Okay. So this is a function from where to where? From? No. Function from what domain to what? To R3, from R3 to R1. Okay. So this graph live in R4. I can't draw the R4 picture. So we want to determine the level surface. Okay. So first, actually, you can okay. I teach you how to break this kind of question, right? Okay, how to tackle this kind of question. So first of all, they ask you to find -1, 0, 1, and 2. First, you actually can check whether this number makes sense or not. Okay? This number can make sense or not. So these numbers are in the range of f or not. Okay, but to know the range of f, you need to know the domain. Okay, so any restriction on the domain or not? No, right, because these are all the polynomials. Okay, polynomials works for every values. Okay, so there's no restriction on the domain, so you can literally get everything out of the domain, and any restriction on the range or not. So these two terms here are positive, right? Okay, but Z can be positive or negative. So you can literally produce all the number. Okay, so these are everything. So let me write down. So the domain is everything R3. The range is also everything. Okay. So note that this range, right, always live inside our core domain. Okay. This is core domain. This is range. Sorry, this is domain. Okay. Okay. So we want to find the level surface. So level surface mean what? You need to set our surface, set the function to equal to some k. Some k. Let the surface equal to some k. So in this case here, what kind of k we have? We have like k equals to -1, k equals to 0, k equals to 1, k equals to 2. Okay. And we get z minus x squared minus y squared equals to -1, z equals to x squared minus y squared equals to 0, z minus x squared minus y squared equals to 1, z equals to, sorry, z minus x squared minus y squared equals to 2. So what kind of surface is this? What's this quadratic surface? You don't remember? Can you remember or not? Last time you asked me about this. Paraboloid. So what's that thing again? I forgot already. What's paraboloid? What's this shape? You have to check what's the shape is. Go back to the quadratic surface. Okay, let me see. Yeah. Let me see. So this is why you learn the quadratic surface and section, conic section. When you draw the level surface, you will meet these surfaces. Okay, so we have 2 square, 1z. 2 square, 1z. So either this elliptic paraboloid or the hyperbolic paraboloid. Okay, one of these. But we have 2 minus, okay? So our sign for x squared and y squared is the same, okay? You can see that the difference between these two is, for elliptics, the 2 sign for x squared, y squared is the same. And for hyperboloid, one of them is positive, one of them is negative. So for our case, we have both minus, so the 2 sign is the same. So we have elliptic paraboloid. Okay. So we have elliptic paraboloid. Huh? What do you mean by circular? Oh, wait, let me see. Uh, I mean, uh, uh, I mean, what do I mean? Did we mention what's this A and B correspond to? What's this A, B correspond to the shape on the paraboloid? Is the radius or not? Okay, yeah. But in general, we call it elliptic paraboloid. Yeah, in general. Okay. Okay. So you can see that there are extra stuff coming up here, so you can combine them with your variable, do some completing square or shift. I think shift or completing square. Hmm? Okay. Okay. So you can see that these are the shift on Z. Shift on Z. Okay. But this one is get shifted down, and then when you go up the level, it gets shifted up. Okay. Yeah. I mean, yeah. Any question or no? No. Okay. So level surface is you just set your function to equal to some fixed number. Okay, and then you see what's the shape. Because it's just a number, right? Usually the shape wouldn't change much, but what it changed is the radius or the position. Okay, keep going. Okay, so there's few more examples you can try. So if you have just briefly discussed, you have this x squared plus y squared plus z squared, right? Okay. So if you look at different level surface, you also get the sphere. And then this x squared minus y minus z squared. Okay, what's this? So you can see that this is having two square term potato chips. I think this one is this guy here. Okay, it is this guy here. Hyperboloid, hyperbolic paraboloid. Right, because you have x squared, z squared, and then minus 1. Is it right? Yeah. So I think you get this guy. Okay, you get this guy here. Okay, let's continue. Okay, we have looked at these surfaces. Okay, so we want to do calculus on it. So we need to define what is limit. Okay, define what is continuity, and then define what is derivative. Okay, we want to differentiate. Okay, we need to do all this. Continuity, what's continuity? Recall what's the idea of continuity? Should we recall limit or recall continuity? Okay, how about recall limit first? Let's recall limit. Okay, let's recall limit. Okay, so let's have some graph. Okay, and then let's take up this point here and then go up. Okay, so I draw it in the function of one variable form. So you can imagine you have two variables here. Okay, so your graph live in R3 also can. Okay, you can imagine, but for simplicity, I just draw this first. So what's this limit to this point here? Let's call it A. Okay, how about we just draw two dimension then? So let's just draw two dimension. Y. Okay, here is Z. Okay, so here, this point here, let's call it A or X0, Y0. Okay. So what's the limit of this f x y at the point x0, y0? Okay, what's the limit? Okay. So meaning if I go from somewhere on the plane, okay, to this s0, y0, they should get the same number. Okay. So if my xy is approaching to x naught, y naught. So let me write down sy approaching x naught, y naught. And x naught. So let me write down. So okay. So let me call this L. Call this limit L. Okay. So we will say that limit of xy going to x naught, y naught of fxy equals to L. Okay. What's this definition here? If I look everything between L and L, okay, let's fix some range here. So intuitively, right? So when you want to talk about this function approaching L, you say that there's some point of fx is getting closer and closer to the number L. Okay. So in other words, what do you mean? So if I look around L, okay, if I look around L in my range, okay, I can find point in my domain that get maps into the range here, right? So if I get this domain smaller, okay, I still can find some fxy inside here, okay. If I reduce the range again, I can still find some fxy here. So I get closer and closer to L. Okay, so this is the idea of infinity. Infinitesimal, not infinity. Infinitesimal. So infinitesimal means you're getting smaller and smaller in infinity. You can see. So if you want to limit to L, right, you need to be able to find something close to this L. Make sense? Make sense or not? Okay. So let's give you another example, a non-example, right? So let's pick another color. Will you say that this limit converge to M? Let's call this M, orange. Will you say this limit converge to M or not? Huh? Limit of fxy, limits of my function converge to M. Will you say this? Huh? Why not? Because use my argument just now. Because what? Because if you go closer to M, right, you cannot find any point in fxy anymore. Okay, but if you go large enough, actually you can still find point in fxy that's far away from M. But if you go closer to M, right, you cannot really find fxy near to this M. Can or not? You can think about it, but you need to make sure you listen the right thing first. Okay, so you wouldn't say that this function converges to M because if you go closer to M, right, you cannot find any point in your fxy. Okay, make sense? So I repeat again, if this function converges to L, okay, limit to L at this particular point here, around this L, right, you still can find point in your function, right? Can you see? So no matter how close to L, I still can find some yellow point of my function, right? Okay, but at M, we cannot do it. Okay, if we go super close to this point here, we can never see my f anymore. Right? There's no point from the function that is close to this point here. Okay. Okay. So I don't repeat this epsilon delta thing, so you can read about it. This is what I meant, explained just now. And this definition also doesn't apply to you. You don't need to use this. Okay, later we will introduce some tools to calculate limit. Okay, don't worry. So the idea of limit is f of AB need not be defined. What is this AB here? So in our case here, we don't need to care about whether this point exists or not. Okay, it can be empty when we talk about limit. Okay, we don't care. Okay, I can even define my function piecewisely and take f of s naught y naught here. Okay, that's fine because I don't talk about continuity yet. Okay, I just talk about limit. Okay. Okay. What? Oh, it's lost already. A bit lost. A bit lost. Okay. No question or not? Question. No question. For those who are lost, huh? Just lost. Where you lost? Where you lost? Where? M, huh? Or M. Or M. Okay, here, M, huh? Okay. So M, I was like, okay. So my statement is this function here, okay? So this function here have limit to this particular s naught y naught here equals to L, but not M. Okay, this is my statement. Okay, so how I see this? So I need to look around L. Okay, I look around L. Okay, see if I can find fxy that's close to L. Okay, I claim that you can do it for L, you cannot do it for M. Okay, so when we take a range, an interval between L, okay, you can find fxy that is close to L. Okay, no matter how small you pick the range, you still can find point that is close to L. Okay, you can try. You see, I reduce to very, very small interval. I still can find my point fxy that is close to L. Okay, but I cannot do it at M. Okay, I cannot do it at M. Okay, yeah. M is a point on the line, on the codomain. Yeah, on the codomain. Yeah, you need to know what line you're talking about. There's a lot of line here. So it's on the codomain. It's not, it's on the codomain. It's on the codomain. Codomain is what? The limit of the function. The image of the function. No. So our image live in codomain. Okay, not necessarily equal. Our image of f is only subset of our codomain. Okay, when it is equal, we call it surjective map. Next semester you will learn. Discrete math, right? Yeah. Okay, huh? Yeah, okay. So I claim that for this point M, right? Okay, when you go smaller and then you look around x naught, y naught, you cannot find fxy anymore. There's no value close to this point here. Okay, so the limit is not equal to M at this point. Okay, so limit have two information. Okay, limit of fxy, and then you need to tell me how to take this limit. This xy have to approach to where? Okay, there are two limits here. Okay, I mean two information in our limits. Remember? Yeah. So you look at how domain approach to one point, and then you look at how function approach to that point. The function of that. Okay. Yeah. Okay. So I mean, doing calculation doesn't help much understanding this, but when you apply when you read question, maybe you'll need this concept here. Okay. So First note is I don't need to define what is FAB. Okay, at the point you want to find the limit, right? The actual value doesn't need to be defined. Okay. So let me write down some comment here. The the actual value of f at the limit point doesn't need to be defined. Okay. Just now we didn't define this point here, right? Okay. It's okay we don't define this point. The limit still exists. Remember? Yeah. So like what we mentioned last time, we keep mentioning about this limit. The special part of this limit here, right, is not we care about what happened at that point, but we care about what happened we approach that point. Okay. Yeah, I saw your classmate. How she sell? Huh? Then outside. He's enjoying his juice. Okay, next. So if the limit exists, fxy must approach the same limit no matter what path takes to approach AB. Okay, so this is what I said just now. So in one variable case, right, there's only one way, two ways to go to a point X. You can go from the left or go from the right. Okay, but in 2D, you can really take any path in 2-dimensional. Okay, yeah, go out a bit. Yeah, yeah. Okay, so in 2-dimensional case, you can go to the limit no matter what path you take. So in 1-dimensional, you only can take left or right. Okay, left or right limit. But in a higher 2-dimensional case, you can take literally any path. Any path. I mean any path in 2D. Okay, no need to be straight path. Okay, so one tips to show, let me see. Okay, so one tip to show that a limit doesn't exist. So to show that a limit exists, you need to show that the fxy approach to the limit, to the same limit for all paths. Okay. So if you want to show that the limit doesn't exist, what do you need to do? What can you do? What can you do? So you just find two paths that give you the different limit. Okay, then you will get the you won't have limit at that point. Okay. So let me see, do we have examples or not? Yeah, let's finish at this example and then we'll take a break. Okay, so before we do some example, right, I need to give you some tool first because we don't want to use the classical definition, so we need to use this tool here. Okay, so this is a tool. So this is a tool to tell you how to find a limit of a polynomial. Okay, because polynomial is continuous. So if you try to find the limit of a polynomial to a particular point, what is that? You just evaluate the polynomial at that point. Okay, because polynomial is continuous. Okay, and then it is defined at every point. Okay. Similarly, if you once you know how to find limits for polynomials, you also can find limits for rational function. Okay, P over Q. Okay, provided Q at that limit point is not 0. Okay, because we need to deal with quotient. We need to do division. Okay, so you need to make sure the denominator is not 0. Okay, and then the last part is if your numerator converge to something equals to L, which is a finite number, and the denominator converge to 0, then the limit doesn't exist. Again, doesn't exist. Because L over infinity is undefined. Okay, so why I tell you this? Because we want to compute this. Okay. So what is this? So just now I already told you the polynomial, right? Okay, so let's look at this. This already found some limit behavior for this function here. Do you know how to read this chart? No? Okay. So you can see that we want, okay, let's draw some diagram here. Okay, so let's look at this part here. This is a function in two variable. Okay. So this is a function in two variable. Fxy. Okay. So where does this graph live in? R3, right? Because R2 plus R, so R3. Okay. So we want to study the limiting behavior to the origin. Okay. So we can go from various ways. Okay. Go from various ways. Okay. So this is exactly done by this diagram here. Okay. So how you place this diagram? So you can like rotate this diagram here. Okay, rotate this diagram here and then move it here. Okay, and then this point here represent the number in the z direction. Right. Okay. So if you input, let's say if you input -1, if you input -1, 0 here, okay. So where's -1, 0 in this table here? So -1 is here, okay, 0 is here. So above this point, this is 0.841. Okay, okay. So you can see that what's going on here. So if you approach along this x-axis here, you can see that it approached 1 on these two directions. Can you see it? Okay. If you approach along this y direction, it also approached 1 to 0, 0. So this is the point of 0, 0. Okay. But notice that why we have a blank here. Why do we have a blank here? Not defined. Okay. Because this function divided by 0, 0 is not defined. Okay. But do we care about the function at that limit point? No, right? Okay. No need. So we just need to care about the limiting behavior here. So if you go along other path, right, and then close to this point, you can see that this is 0.99999. Okay, 0.99999. So if you get closer and closer, you will eventually get 1. So you go from any direction, close, you will get 1, 1, 1 forever. Okay. So no matter what path you pick, okay, you can pick this crazy path here. But when you want to go close, right? So what we care is when we go really close to the point 0, 0. Okay, you will start with this 1. Make sense? Make sense or not? Okay, you can go from left, go from right, go from top, go from bottom, and then go diagonally, and you also can pick some crazy one like a snake board, also can. Okay, but you eventually, the last part here will start with 1. The place you take the path is R2, is the domain, and then where you take the limit is in the codomain, is in R. R, actually just R. Right? Fxy give you a R. The whole thing live inside R3. Okay. Yeah. The value here is just R. So you are just taking limit of real numbers. Right? Then you see here all are real numbers. You are taking limits of real numbers. Okay. But this number here controlled by something in domain. In R2. Okay. So we conclude that no matter what path you take, the limit is just 1. Make sense? Is it okay? Okay. Okay, so one last example before we take a break. So similarly, we have another function x squared minus y squared over x squared plus y squared. So now we already know how to read this table, right? So why is it empty in the middle here? It's not defined, okay? Because you divide by 0 again. Okay. So can you find the limit of this function in this case when approaching the point 0, 0? Does the limit exist or not? Why? Precise a bit. So you approach different value from different path. Okay, so if you pick left, right, you approach -1. But when you pick top and bottom, you get 1. And then if you pick diagonally, approach 0. Okay, so which one I need to approach? What slash? What slash? Another meme. What slash? Okay, so you can see that if you go from different direction, you approach different number. Okay, so the limit doesn't exist. Yeah. Later we will have some more tools to help you. Okay, now it's just getting an idea first. Get idea first. Huh? No. I mean get idea first. Later we will have more tools to calculate. So it doesn't exist because they are no. Don't be stupid. Don't compute like this one by one. But I'm just showing you an example only. Later we will have more tools to calculate limit. So does it exist because they are half that there are paths such that x squared minus y squared over x squared plus y squared meeting different values and taking xy to 0, 0. Okay, so you see, when I write here, right, I need to talk about the limit of my fxy and also what point I'm taking. Okay, what point I'm looking at. Okay, now we are looking at the origin. Okay. And then when the xy approach the origin, what happened to my fxy? Yeah. So this is not how you find yet. This is just an idea to show you when it exists, when it doesn't exist. Later we will get more tools to compute limit. Actually, I already told you one tool to compute a limit just for polynomials, right? Only for polynomials. But this is polynomial, but the point is not very useful here. Because if you look at this limiting to 0, okay, you can see that the denominator going to 0, which is lie inside the case where the limit doesn't exist, or it's not clear whether it appears. Okay, so let's take a break first and then 0. Yeah, break first. 917 will 917. Yeah. Midterm. 10 o'clock. Yeah, we can do it now. So if you get your midterm, you can do it now. Huh? You help me check one by one. Okay. Huh? Is it okay? Yeah, so you can one by one get your midterm from Tsinghua.
哎，能听我，我还没打。
帮我看一下，
要的是你，最近贴的也是你。
一人拿一个。
一人拿一个，找自己的，找自己的。
090，090， 935。
And for those who haven't come, don't take for them. Don't take for them. Only take for yourself.
077， 096。
啊？老师，你有回答？
有什么？
有啊。
什么意思？
别了吗？
要多拿。
Yeah, just take for yourself.
你跟我扯话，让他们自己来。
不能开我垃圾你好了。
有些人分数被别人知道了。
这是全部加起来，
有些人
没有对哦，真的吗？
啊？什么？
真的啊？
先不要。
都到。
Yeah.
我有一个部分，我要死别了，我这里有，我感觉我那10分哦，你看低，不怕。
不是你来。
96很高的，比较高。有95，有。我怎么会？有稍微有一点高，但是在看。红姐。
很好。
这个。
老师说，
哎，
这一个分都不给啊。
What do you mean? Later we discuss. Yeah. Later we'll discuss. Don't worry. Later we'll discuss. If you have mark later can discuss. Don't worry.
我们小几号位？不想讲。
Don't worry. Later we will discuss in the third hour.
还是被我改错这么分了。对，99。
我起来。
那边，我没有来过。
When can 的 When can。
借我那里。
一下，要看你在喝茶。你在喝茶。
是刚进来的，就我们要吃过来的。
真的。
你拿完给你夹掉。
这总会100块。
你会？
好了。
这个会跟你加完起来是吧？
哎，你有。扣2分。
对，找问题啊。
对。
所以我就扣2分。
我都说我每天都没对，所以谢谢你手下留情。
扣2分，这么牛逼！
接受了，谢谢你手下留情。
一个新的还是问题啦。
谢谢你手下留情啊 ，OK。对，
牛逼就扣2分，那也是
开心啊！
一看就是你们的了。
哦。
Just take your own test paper. Don't take for the one that I answered.
OK。
好的。
对的呀。因为我是可以接受，因为我知道是我妹可能都没时间里，
还可以招。
下次我努力 final 不要丢你。我装多点强，真的，确实的。
真的要。
你还可以看到我在 final 还在吗？所以他这个是我用 2D 来看，然后我是这样子。
Yes。
因为我有2个 variable 啊，所以我可以这样子看。如果我一个 variable 我就
3个。
这样子。
You can take picture of your. Don't take photos. 这个好了。还好啊。You can take photos of your test paper. You need to return later. 要有 return 的一个 calculator。
at least 白天就好什么，决定想啊，至少在我一个星球去读10分我就算了。
天，我出来，哎哦，
看一下，
我是要什么号码跟我的关？
那样可以扫。
要这个看这个看这个就好。
这个谁啊？等一下，等一下。
怎么能这样？你看你，你故意的，你就是故意的。你看见我其他的，
哪一题？哪一题？我改了，我给你把分担。但是改变自己，但是我改的。
对呀，就
那边签了。不要。
你改了，
改第几题了？第二题版本。是啊。
老师，那你看怎么我是可以得？呀，不对。
你要1分钟扣了。
什么？我知道，我被扣没办法，我少写那个东西。我知道
没有，我知道我着急，但是没有时间写了。
哦，
这个部分的那个，然后我就写的好帅，然后没有想到1分都不给。
不要看这，不要。
你95，你刚才跟我大声讲笑。
是我就可以拿分的。
对，那
如果你这个比较那有100分，我在想
100分。
你问谁？我记得这里不用说。
我当时，
对，你看你其他。等一下，我等一下，等一下。
我都错快了，可能傻逼了。
但是可以看他要不要打一个。你在讨论过后，你再来。
我在看着你看下面，然后比有什么地方那个是打破。
这样子吗？
每个地域快2分。
哦，你这个在考。等一下，我考虑过后。
啊，这样。他对，他对，他要打他的一样，哎，这东西不一样，这个是不一样。
哦，他们有看今天这个水平比较。
感觉不一样。我跟你讲，我开始我是简简单，
一开始这样的话，我是做完后面，然后我们再看，没有大概放。你到一开始先的话，对我的。
这个是花掉的接水的题。
那你没有刚不可以，人家哪一个有一的，要有一个没有刚刚
你考试过都会用谁？
默认你的步骤。
开始这种。然后这个点的时候。velocity 不是 speed。speed 是这个 velocity， 是不是这个怎么可能呢？对吧？它是等一下会讨论的，等一下你再跟我讨论。好，来，你的方法是什么？没有改到？
还是没有分啊？完了，不会。
等下，讨论完这个可以来这个这个。
这个 P series S， 然后这一步呢？这步你有说吗？对呀、可是因为你都知道是万是它大部分统计，我知道这个统计啊，但是怎么告诉我这个统计不统计？啊，要上嘞，已经上了。Hello, testing. Okay, so I let you keep your midterm exam until the end of the class.喂，怎么可以这样子说话？可以，这个可以。啊，一个人拿99，是我记不人。我天！哎，where's the rest 啊？Let's start.
以后我的宿舍考试了，你们 F 怎么样？
怎么样？
40%。
wait let me bring something up. Okay, so please keep your midterm first. Later we will discuss, and then after we discuss, you can come and claim mark, but don't write anything on your midterm first. Yes. Later you show me. Later you show me. Okay, later you show me. Okay, because these are like marked by different people, so yeah, so we need to check. Okay. So just now we have some. Hello, wait. Hey, keep your midterm first. Hello, keep your midterm first. Yeah, keep your midterm first. Later we'll discuss. No worry. Later we'll discuss. Okay. Okay. So property of limit. Property of limits. Okay. Just now what we have learned, we know how to find the limit of polynomials. Okay. where we just substitute the limit point into our function. Okay, because polynomials are continuous, so we can do that. What else we can do? So if we can know the limit of our term, our function, we can just sum them. We can look at the limit of sum. Okay. So for example, let's say limit of okay, let's assume something y equals to L, and then limit of gxy maybe equals to m. Okay. So let's say these two limits exist. Okay. Then what we can do is we can consider the limit of x plus g. Okay. So let's write down this notation here, right? Okay. So we keep the notation brief. How about I write it all first and then let's keep it brief later. So if we consider the sum of two functions, okay, then we consider a limit, it's the same as we take the sum of the limit. Then we take the sum of the limit, which is just L plus M. Okay. So this is what it means by limit of a sum is the limit of the limits. Sum of the limits. The limit of a difference is the difference of the limit. So if you take f minus g, limit of f minus g is equals to the limit of f minus limit of g. Okay. Is it intuitive or not? Intuitive or not? If you take difference and then you just take the difference of the limits. So similarly, if you take the limit of a constant multiply a function, okay, it's just the constant multiply the limit of the function. Okay, so it's like linearity. So this is like a linearity property. Okay, linearity property. Wait, quick. Relax. And yeah, I get from other class one. Later I will include in our notes. Yeah, because your previous note is a bit I don't like. I don't like. Okay, so you also have similar slide, but yeah, I don't want. So I will include it in my version later. Okay. Okay, so limit of a constant time of function is the constant time the limit of the function. So you can take out the constant when you compute the limit. Okay, so it's like linearity. Remember the linearity? F of x plus y equals to fx plus xy. F of cx equals to c times fx. So you can pull this constant out of the limit. You also can split the sum into sum of limit. Provided what? Provided the limit already exists individually. Okay. For f exists, for g exists, then you can sum them together. You can take difference of them together. You can multiply them with constant. Okay. And you can even take the product of them. Okay. If you consider the limit of gf is actually equals to limit of g times limit of f. Okay. If you can consider the products, you also can consider the quotient. Okay, you can divide two functions together. Limit of g over f is equals to limit of g divided by limit of f. Okay, provided limit of f is not 0. Okay, provided limit of f is not 0. Okay, so there's some significance here, right? Hey, don't discuss midterm first. Okay. So keep it first. So there's some significance here. You can see the left-hand side here, you are taking a limit of a function. Okay, the right-hand side here, you are just operation on number. Okay, operation on number that you already know. Yeah. Okay, so meaning you don't need to check the limit again. You just use what you already know, okay, to compute. Okay, you just use what you already know. Okay, so 6 is this special limit here. So if you just take limit of x, okay, but you're considering this 2D path here, xy going to AB of x. So x is just limiting to A. Okay, doesn't care what y is doing, but x is limiting to A. And if you take limit of y, where xy go to AB, so what happened is y is keep approaching B, but you don't really care about what happening to A because your function only care about y. So next is the usual limit of a constant number or constant function is always just the constant number. Okay, no matter what path you pick. And then this part here is what we have gone through just now. Okay. So let's try what we have said just now. Okay. So how to compute this limit here? Okay. So you are computing a limit of a function x squared y plus 3y. Okay. So this is a function from R2 to R. R2 to R. Okay. Where you send xy to s squared y plus 3y. Okay. Okay, so now, right, you should really imagine a surface inside your mind. Okay, I don't care what kind of shape you imagine because shape doesn't matter now. So what you should imagine is you need to look for this 1, 2 point inside your domain and then take any path, go to this 1, 2, and then see how this x squared y plus 3y flow into x 1, 2. You need to have this imagination because later we will do derivative. If you don't imagine, right, you will be suffering. Okay. If you can't imagine, you will be suffering. Okay, so you have this surface here, then you go to 1, 2, this point. So how to compute this limit here? So what's the thing inside this function? What are these? What are s squared? Y? These are, yeah, it's parabola. So these are actually polynomial. Okay, polynomial and products of polynomials. Right, x squared y is a product of polynomials. X squared y plus 3y is sum of polynomials. Okay, limits of a polynomial exist or not? Exist, right? Because we say that polynomials, the limit of polynomials is just evaluate that polynomial at the point. Okay, so really what we do, so what we really do is we split the limit into polynomial first. So mathematics is like this one. Okay, how to excel in mathematics? So how to excel in mathematics is you need to know the operation on simple object first. Okay, and then we use this simple objects to combine together, find a more complex objects. Okay, so let's say this x squared y plus 3y is a complex or complicated object. How we break it? So we break it into sum. We break it into products. Okay, so we ask ourselves, do we know the limit of the term inside our sum or not? Okay, do we know about these two or not? Okay, so this x squared y actually is still complicated a little bit. Still a little bit complicated. We can further break it because this is a product of two polynomials. So we can further break it into x squared and y. Okay, I really want you to appreciate these breakdowns. This is how you should think about mathematics. Otherwise, you don't know what we are actually doing. Okay. Okay, so we have this thing already. Okay. Can we break it further or not? Huh? What is SSY? Huh? another meme. Okay, so can we break further or not? So we can break further down into x, just x. Okay, we can break further into just x. So let me resize this guy. So let me show you what's the stage we need to think about it. Okay. Okay. 3y. Can we further split it? We can split it into constant and 3. Okay. Okay, I'm going to show you how we split and then how we combine all the things together. Okay, so you can see to the last stage here, we only care about x, y, and constant. Okay, so this is why we introduce this line here, number 6 here. This is really important here. Okay, because every polynomial can just split into these 3 cases. Just break down into these 3 basic cases. Okay, so for example, what's the limit of x when xy goes to 1, 2? Okay, it is just 1. Okay, and what happens to y when you take limit from xy to 1, 2? It is just 2. Okay, limit of a constant function, no matter where you go, you still get the constant number. Okay, similarly for this is 2. Okay, so once you know what happened to limit of x, do you know about what's happened to a limit of x squared? Huh? You just take the square because the limit of a product is the product of the limit. Okay, so limit of x squared is equals to the limit of x times limit of x, which is 1 in this case. So 1 times 1 equals to 1. Okay, so you already know what happened to x squared. You already know what happened to y. Do you know what happened to x squared plus y times y? Also taking the product of limit of x squared times product of y, which is 1 times 2, which is 2. Okay. So if you know about the constant, limit for a constant, know about limit of a function y, do you know about 3y? You just pull the constant out 3 times the limit of what? Y, which is 3 times 1. 1 equals to 3. So this is the constant method. Wait, 2, sorry, 2. So it's 6. Okay. Okay. So what you can do, what can you do is you use the constant property of the limit, or you can use the product property of the limit. Okay, so actually there are 2 ways to go to this 6. There are really 2 ways. Can you see the 2 ways? You can see 3y as a product of 2 functions. Okay, then this limit is equal to the product of 2 limits. Or you can use this property here. The limit of a constant times a function is the constant times the limit of the function. So you can either see these 3. So you can either see these 3 as a constant or a constant function. Okay. Okay. So this is a university level mathematics. So I don't want to just tell you what you need to do. You need to know what you're doing. Okay. If you don't know what you are doing, you are equivalent to those who don't come to university. Okay. Yeah. Seriously. So don't waste your money. Okay. Okay. So I want you to appreciate what you are doing. Okay. So once you know about s squared y, limit of s squared y and 3y, right? So what happened to the limit of this sum? It is the sum of the two limits. Okay. So this is the last part we want. So we look at x squared y plus 3y equals to limit of xy goes to 1, 2 of 3x squared y plus the limit of xy go to 1, 2 of 3y equals to 2 times 2 plus 6, which is 8. Okay. So if you want your computer to compute this last thing, right, you need to tell the computer everything for the atomic level. Okay. I call this the atomic level. Okay. So you build from this atomic limit. Okay. Okay. So what you need to tell, your coding, you need to start from here and then give them the theorem, and then he will compute this number here. Okay. Okay. So once we know this, I don't think we need to repeat this whole process. So let's try one example on how should one really write down. So let's look at the second example. Okay. So this example here is a quotient of two polynomials. Quotient of two polynomials. Quotient of two polynomials. So the theorem says if the limit for numerator and the denominator exists, right? Okay. You just substitute the point, the limit point that you want to find into the function, and then you just take the quotient. Okay, is it true in this case or not? Okay, let's read the statement again. So assume, okay, limit of f and g exists. The limit of a quotient is the quotient of the limit, provided that what? The limit of the denominator is not 0. Okay. So what happened in this case? The limit is 0. Okay, so the limit is 0. Okay. But not yet. So what's the limit of the numerator? 1. Okay, which is not 0. Okay, remember what we talked about rational function at first. If the limit of the numerator is not 0, but the denominator is 0, the limit of the denominator is 0, then the limit doesn't exist. Okay. I didn't show you why it is true, but you need to use it. So by theorem, just now, the limit doesn't exist. Doesn't exist. Okay. Okay, next, show that the function fxy has no limit at the origin. Okay, so just now, what is the strategy to show there's no limit? Limit exists if and only if you go approaching from all paths, okay, the limit is the same. So to show that it doesn't exist, what you need to do? To show that the limit doesn't exist, what do you need to do? Find? No, don't do the table. Okay. So what's the principle of the table? You need to find paths that give you different limit. Okay. Right. So in particular, you just need to find 2 is enough. Okay. Okay, what kind of path you can take? Okay, the easiest path is going from the y-axis or going from the x-axis. This is the 2 easiest one. Okay, if you want to go diagonally, how to take diagonal path? Y equals to x or y equals to minus x also can. Okay, so let's start with easiest one, right? Okay, let's start from easiest one. So we can go from we can go from x-axis first. Okay, so what's x-axis? How you describe x-axis? Are all the point where y equals to 0. Okay, so when y equals 0, what happened to your function? You just get x squared over s squared, okay, which is equal to 1. So f(x0) equals to 1, limit of xy to 0, 0 is what? It's still 1. Okay, so we are actually, when you see constant function, right, you should feel happy because no matter how you take the limit, you still get 1. And how about the other way? So first can anticipate. So let's go from y-axis. So y-axis are the point where x equal to 0. So f(0x) is what? Hey, sorry, what am I doing? 0y. Okay, so what is this? You get minus y squared over y squared, which is equal to minus 1. Okay, so in this case, the limit is just equal to minus 1. Hey, I cannot write this actually. I cannot write this, sorry, I cannot write this. This limit here only work for the all path if it is true. Okay, please erase those two. I cannot write that. Yeah, right. Yeah, right. Yeah, right. Unless I will produce another notation for it. Yeah. Okay. So what are we showing here? So we are saying here different path lead to different limit. Okay. So the limit doesn't exist. And so you need to be careful, right? When I said the limit, limit of what? Okay, limit of a function. Limit of function still not enough. I still need to say where the point limits to. Okay, so two information here. So sometimes I just abbreviate to the limit, right? So I assume you know what limit I'm talking about. Otherwise, I need to say the whole thing, keep repeating the whole thing. Okay. So once you unsure what limit I'm talking about, you should just point out what limit I'm talking about. Okay. Yeah. Okay. So next, this one, I think we see some similar stuff. Sine of x squared plus y squared. Yeah. Yes. Yes. Test for other part that give you different limit. You can test diagonal. You also can text y equals to x squared. Also can. So any path in two-dimensional space will work. You can anything, but e to the x also can. Okay, that one is polar. Okay, once you turn into polar, you also can take that one. Yeah, e to the x. Yeah, because you already showed that you approach two different paths, you get two different. Okay. Okay, next new tool to show you how to find limit. Okay. So here, right here, you don't quite have the polynomial with you because what? Because sine is not a polynomial. Okay, so you don't quite you can't quite apply the theorem here. Okay, so what do you do? What we can do here is we can use polar coordinate. Okay, we can use polar coordinate. Yeah, we can use polar coordinate. Okay, don't throw away first. You can use polar coordinate. Okay. Yeah, you can use polar coordinate here. So remember the polar coordinate, x equals to r cos theta and y equals to r sin theta. Okay. So if we want to do this change of variable, okay, what do we have? We have x squared plus y squared equals to r squared, okay, which implies that r equals to square root x squared plus y squared, okay? Because we want to change variable, right? We need to know how to change our variable of this limit point, okay? So when we take xy going to 0, 0, you are going from all path, right? Okay, so meaning the radius is going to 0, okay? Because you're going closer and closer to the origin. This is what polar coordinate capture. Because polar coordinate centered at 0, the circle, all the 0, the circle. Yeah, you hope you still remember. So actually we're approaching 0 from the positive, right? Yeah. So geometrically, what you are doing, okay? Because in R2, we need to approach origin from different path, okay? So somehow when you turn into polar coordinate, you are just shrinking your all the path. Okay? So you shrink every possible path. So it's kind of powerful in this case. Okay, so you shrink. Okay, so let's see what happened to our function in this case here. So xy go to 0, 0 of sine x squared plus y squared over 3x squared plus 3y squared. Okay. So after change of variable, can you see what happened? Sine x squared plus y squared become r squared. And then the denominator become 3r squared. Okay. So you see, your function become a one variable function now. Okay. Can you do limit in this case? Yeah, you can use L'Hopital rules, or after you use the L'Hopital rules, this is sine x over x. Okay, this is just 1. Okay, so I need to recall that the limit of sine x over x is just 1. You can use L'Hopital rule to show this. Right? You can use L'Hopital rule to show this. But how you remember this is sine x when it's starting, right, close to 0, 0, it's really the same as y equals to x. Okay, so sine x and y equals to x is really the same. Okay, yeah, so this is the polar coordinate method. Notice that when we do this, we are considering all path, right? Because when you shrink the circle down, you are like consider all the path that shrink down to the origin. Okay, so polar coordinate check for all path. And that's why we like polar coordinate now here. Okay, so far okay. Just feel free to stop me. So I keep going first. Okay, so in this case here, we also can use polar coordinate. Okay, so when you see this something square plus something square, right, you should think of polar coordinate already. Okay, because it's the easiest way we can combine the term. Okay, so in this case, we also try the polar coordinate method. And what's this limit here become? Going this point here also converging to 0, 0. Okay, similarly. So the radius is going from positive radius to 0. So xy will become what? R cos theta times R sine theta. Okay, over R squared. Okay. So You can see that you can cancel r squared from the numerator and denominator, right? So what you left with is cos theta times sin theta. Okay. So what's this limit here? Huh? What's the limit here? Huh? There's no r inside the expression, right? So you just get cos theta times sin theta. So what does this mean? This limit has theta controlled by theta. No. So if I change theta, this number will change. Okay. So this means that different values of theta leads to different limit. Right? What does theta mean? Theta is the angle that comes from the positive x-axis. Still remember no? Still remember? The theta of our polar coordinate is the angle that comes from the positive x-axis, the polar axis. Okay. So if you go from different angle, you will get different limit. So different path lead to different limit. So the limit doesn't exist. Okay. So the sequence doesn't exist. So just now, right? Just now we say that if the limit doesn't exist, we shouldn't write this notation, right? But why we write it? Because we assume it exists first. But we found that it's false prediction. Yeah. Okay. Yeah, we keep going. Again, show that if this exists or not. Okay, I let you try with polar coordinate. See what you can do. Let you try for 3 minutes. I give you a hint, you can start with polar. Yeah, anything what? Any findings? Any findings? Limit exists or not? Huh? Can the limit be computed? Can the limit be computed? This is the quotient of two polynomials, right? Okay. So if you use the theorem, you get something 0/0. Don't know whether it exists or not. Okay. If we use this polar form here, we can't quite get rid of the r yet, right? In particular, if you sub theta equals to some critical number, for example, pi/2, right? You also get 0/0. So how? Yeah. So how? Can we try some path? Try some path. X-axis and y-axis again. Try some path. And let's try some path. 0. Okay. And then what's this here? It is just 0. Okay. How about try y-axis? Also 0. You get 0/0 or 0? 0. Also 0. 0/0 along. The y-axis you get what? 0. See. So you get 0/y to the 4, which is also 0. Since it seems true, okay, we can pick another way. Let's try another path. Let's try x equals to y squared. Okay, x equals to y squared. What happened to this line here? Huh? Y to the 4 over y to the 4 plus y to the 4, which is half. Yeah, different. Okay. Yeah, so it's different. Okay. 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 At least for this one. No? Yeah, sometimes can, sometimes cannot. So we need to try sometimes. Okay. So once we found two paths that's not doesn't have the same limit, we said that the limit doesn't exist. Okay. So that's why we like theorem a lot. Okay. Because theorems tells you if you have what, then what will happen. But in this case here, you need to try, keep trying, keep trying. What if you can't find the path? Actually, it doesn't exist. Yeah. What happens? You can't find the path. You can never show it. Okay. You can show it only you can found the two different paths that give two different limits. Yeah, so that's the question. Okay. Yeah. Always mathematics want to answer this question. Okay. I don't want you to test like everything, but I need to give you a way to see the answer faster. Okay. So in this case here, any hint show you these two paths or not? Is there any hint that give you this two paths here? Any hint or not? Any hint? You can somehow observe the symmetry of your function here. Okay, observe the symmetry of this function. So you can see that for the power of x, right, is less than the power of y. But there are some ratio between these numbers. Okay. Yeah, so you need to try and observe the symmetry of the function and then try some number, some possible number. Okay. And then one thing suggesting the limit doesn't exist is when you directly compute the function at that point, it is undefined. This is one of the hints. Okay, hint, just hint. It doesn't say that it must be true, but it's just a hint. Right? Remember just now we have two examples here. It is undefined at 0, 0, okay? But one of them, the limit exists, one of them, the limit doesn't exist. So it gives you a hint, okay? Yeah, give you a hint. But you can't really decide anything yet, it's just a hint. Okay? How about next? This one. Okay, this one here. And this one, I also let you do. You also can use polar. Check. I let you do again. This. Try polar again. Try polar. Try polar. What's the polar function you get? Did someone finish calculating? 3r cos square theta sine theta. Okay. So what's this here? 0. Okay, good. This one is just 0. So this says that, okay, you see, when you write down this equation here, what does this equation tells you? Okay, no matter what angle you go, as long as my radius go to 0, everything goes to 0. Okay, this is exactly telling you that no matter what path you take, you will still limit to 0. Okay, so everything here makes sense. It's just not just a bunch of function or angle or number, right? Hey, why Jinghua so fast keep already? Continuity, then later we'll discuss midterm. Okay. So another method to show this is squeeze theorem. Do you learn squeeze theorem in calculus 1 or not? Yeah, okay, good. So good, very good. So how to squeeze this function here? Okay, how to squeeze this function? So first of all, we can squeeze x squared over x squared plus y squared. Okay, we can squeeze this between 0 and 1. Okay. Do you see why we can squeeze this in between 0 and 1? Over x squared is what? 1. Okay. But I add extra term to the denominator, y squared. Y squared is positive. Okay. So you increase the denominator, surely you are less than equal to 1. Okay. Y greater or equal to 0 because everything inside is positive. Yeah. So this is the squeeze theorem. So when I write this 0 and 1 here, right, do I really mean 0 and 1? What? Wait, sorry. I just feel a bit funny. Oh, sorry. I just feel a bit funny. I don't mean 0 and 1 here. I mean 0 function and the 1 constant function. Yeah. What? So I mean this is the 0 function and the 1 function. Yeah. Okay, never mind. Next, keep continuing. Okay, so the number here is less than 1 or greater than 0. Okay, and then in our case, we want to care about 3x squared times y over x squared plus y squared. Okay, so we can just multiply 3y to all of them. This one is true. Is this true or not? Yes, It's true. True or not? Okay, true in some sense first. Okay, let's keep continue. So if you take limit xy go to 0 of 0 is 0, limit of xy 0 of 3y is just also 3 times 0, which is 0. And then by squeeze theorem, the functions go to 0. Actually, there's a problem here, you know. You know where's the negative? Okay. What happened to y if negative? Okay. So you swap the inequality. Okay. So really, there are two things you need to look at here. So one of them is this inequality. The other one is if y is negative, then the inequality you need to look is 3y greater or equal to 3y(x) squared over x squared plus y squared less than equal to 0. Okay, there are two of them you need to look, but for both of them you can use the same squeeze theorem. Okay, is that okay? Okay or not? Remember just now I said if you multiply negative number, this inequality swap, right? Okay, so you could have this case or the other case. Okay, there are two cases. Yeah, the other case is also the same because you also have both sides squeezed to 0. Just that there's some subtlety here. You need to take note. Okay. Yeah. Okay. So what's about continuity? So continuity now you want to take value at that point by the function. It's exactly like the polynomial, right? Polynomial is continuous because when you take limit to the limit point, okay, that point is actually equal to the value of your function. Okay, equal to the value of your function. So you don't want that when you take limits to this middle point here, you actually have your f somewhere else. Okay, this is not continuous. There's a hole here. Okay, there's a hole here. You don't want to have a hole. You want your function also take value at this limit point. Okay, this is continuity. So say again, to say that fxy is continuous at the point a, b, okay, let's call this ab. We require the f value to have a value at ab and have as a limit as ab. Okay, and moreover, the value is equal to the limit of the value of f at ab is equal to the limit then. Okay. So for example, polynomials are continuous. That's why we have the limit theorem. And then if you have two polynomials, you can take the quotient, or we call the rational function. You know why we call this rational function? Huh? So this is like a rational number, right? But we replace the number with function. Okay? So the rational function is continuous for all xy, but you need to make sure that your denominator doesn't achieve 0 at some point. Okay. So examples of continuous function, what do you have? Example of continuous function. What do you have? You have polynomials, right? You have what? Rational numbers. Rational function. Okay, if defined. Okay, exponential function. Okay, exponential function. Sine, yeah, good. So they are all the trigonometric function. They are all continuous, right? Because Tangent. Okay, so yeah, so let's put sine and cos first. So tangent is what? Tangent is the rational function of sine and cos. So it is continuous only at the point where the denominator is non-zero. Okay, is okay. Yeah. 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 So really what we are talking here is continuous function at every point in the domain, right? Yeah. So you can see the concept or not now. So you can continuous at one point, okay? And continuous at every point in the domain. Okay. So continuity is about only about one point. Okay. Okay. So continuous at a point, continuous everywhere. Make sense, huh? Okay. Okay. You can continuous at a point, you also can continuous at all point everywhere. Tangent continuous at, okay, we should say the tangent is not continuous at the not just pi over 2, right? Pi over the plus k pi something like that. Okay. That's where the denominator go to 0. Yeah. Yeah. Okay. Okay, so let's write down the thing, right? So tangent is continuous except the point pi over 2 plus what? K pi. Okay, I believe you. I don't check. Okay. Can picture this or not? So what we are talking about is exactly this vertical asymptote. Yeah. Okay. Yeah. Okay. Quickly go down this first, and then we will. So if okay, so why? So you see, so why we care about this example here? So we try to build new things again. If a function g of two variables is continuous at a b, and a function f of one variable is continuous at g a b, then the composite function f composed with g defined by f composed g on xy is just you do g first and then you do f is continuous at ab. Okay. So so this says that the composite functions of composite function of continuous function is continuous. Okay. Composite function of continuous function is continuous. Okay. So for example, let's look at this following example here. Okay. Where does this function continuous? Okay. You have quotient of two polynomials. Okay. So polynomials continuous everywhere. Okay. So top continuous everywhere, bottom continuous everywhere. But this function is undefined at some point. Okay. What's the point that this function is undefined? Where the not only 0, 0, where the denominator is equal to 0. Okay. So to be defined, right? To be defined for this function, right? You need to make sure your denominator is non-zero. Okay, which means your y cannot equal to fx squared. So what's this line here? This is the parabola. Okay, so you need to take away this line from your domain. Okay, you need to take away this line for your domain. And then outside this domain, outside this set here, or outside this parabola, this function is defined and it is continuous. Okay, because top is continuous, bottom is continuous, then you put them together is also continuous. So it is continuous, it is defined and continuous at the point where the point is not on the parabola. Okay, makes sense. So to talk about continuous, you still need to talk about whether that function defined or not first. If it's not defined, you don't need to talk about continuity already. Okay. Okay, keep going. So how about this? This is a cost function, and then inside cost function, you have a polynomial. Okay. So you know that polynomial is continuous at every point. Okay. And then you also know that cost function is continuous at every point. Okay. So if you compose two continuous functions, it's still continuous. Okay, that's the theorem. So let me write down here. So here, there are two things here. So x cubed minus 4xy plus y squared are polynomial. Okay. And then cos z is a, you don't want to use trigo, right? It's also continuous. Okay. This one continuous on R2, polynomial continuous on R2. Cos z also continuous on R. Okay. So being composite function of continuous function on R2, f is continuous on R2. Okay. Okay, let's keep this as a mystery. We will solve on Thursday. What? Okay. What? Okay, the last example we keep for Thursday. Okay. How about come back after 5 minutes? Okay, come back after 5 minutes. 10 to 5. Then we will start midterm discussion. 我讨论完先，你再来改。Yeah. Oh, yeah. Oh, okay. He's yeah. Yeah, yeah. No problem. How's your leg, Jiaxuan? Still recovering? Jin花怎么这么累？
老师，求你让我睡一会儿。
哎，
刚那个题目我
呀，哎，为什么你要 y 是这个 square root 的东西？
y 是我听不掰吗？那我也可以变成这个。我的名字是算了。
我清楚，但是这个 chain of variable 是 by Jack 就是允许没？
哪里不允许？就我
哪里不
不知道
允许啊？我想一下哪里不允许啊？
你看啊，这边我的 main point 是我要找出一个点，对不对？然后这个是我全。
哦，我知道哪里不允许了。你看啊，你这个东西啊，你只是 cover 了 y 是 positive 的 part，除非你还要另外做那个 negative part。
哦 ，OK， 好。
对。对。没事哦。哦，你OK，呀，啊，你看，就从我们一开课那个圆圈开始 ，OK。假设你从这边过来的话，从 x axis 过来的话，它是从这边爬上来哦。从 y axis 的话，它就从另外一边爬上来哦。哎，对， 然后呢
有些会 approach 同的 point 的，就像
0 减
你
1，
像刚刚那个1/2，那是讲 approach 1/2的。
OK，可以，就把那个 example 出来，我用电脑画给你看，因为我画不出。呀，用电脑，一定要画电脑，
电脑。
一定要用电脑画，因为画不出。
OK，
你选一下，看那个，我找。
对
OK，
为什么还会
是咯，
approach
一定要给你们看一下比
0，
较好。
然后又有 approach 1的
PD
approach 因为我们是 approach 一个点，
刘老师知道其实
可是为什么我们会有？
它这个分母里面，这个分子里面不是有 r 的嘛？它那个 r 其实0，就是0。
哪里有哪里有？
这个 r 不是分子里，这 r 不是消不掉
可是。你课 cos 还在哦。
可它在你无所谓，你是0啊，你0出一个常数那种。
哦，你的意思是那个所以我这样
但是它这个之后是不存在，是。
对，然后之后其实又不存在啊。
对啊，就那是
给我想一下啊，矛盾哈，没有矛盾啊。你看你这个是 r，就是 r square 耶。
哦
啊，
square，但这个你
也
那没办法排除 cos 其他等于0的情况。就如果它不等于0的话，就是0；那它等于0，那就但是它如果等于0，那就可能
这个比较好看，是这个哈，x y。
是不是它这个
怎么？
它这个就是
也
怎么想到这个 x 等于这个
哈，因为要看，对，要看它的这个它的 symmetry， 对哦，对呀，
有点悬。
圆的话呢，因为你看哦，你拿到0嘛，你就要想能不能造出一个不0的东西嘛，然后要怎么想怎么造出一个不0的东西，你就要想能不能消掉拿到1之类的东西。
是会出这种题。
都不能直接算0的吗？
啊？
就像他刚刚讲的，
不能，因为 cos 其他有可能等于0。
哦，
因为不要看下面，哎，出来了我们从哪里我们去到0？给我看一下，看一下怎么解释。如果你看你看，我是反的啊，我没有反，哎，我想一下，OK，你看啊，OK，如果从x axis 对不对？x axis 跟 y axis 它都是去0哦，看它怎么理解。你看 x axis 的话，你看整条都在0。对，是这样讲吗？不是这样讲，应该是说去 x axis 的话，你看，当它靠近这个给我想一下啊，哦。y 等于0，y 等于0是什么情况？y 等于是这一边，
就走 x 是吧？
所以全部人靠近这个 x axis 的时候，你看全部值都要去到0，看得到吗？你看这个，你看，全部人这样子上来，再看一下另外一边呢，你看另外一边是下面上来上面下来，看得到吗？OK 啊，然后这个是 x axis 哦，然后试下看这个 x 等于 y square。OK，x 等于 y square 是什么情况？你看，全部人靠近 x 等于 y square 的时候呢，哎呀，他怎么这样？哎呀，怎么他不给我装啊？
我摸那个分
怎么他这样？哇，这样，天呐，他卡了。
那老师，如果你看这里，它不是还是去0吗？
你给我看一下啊。对，他中到有点烂，有些他只是补充罢了。我们先看一下他的 behavior。哎呀，不见了。哎，他真的不给我调还是要按这个先。要按这个。等下我重新打一下。
老师，你这什么网站
？3D plot。我只是觉得这个颜色比较美，比较喜欢吧。
你这个能不能把这个网站链接就是
放在
Word 上？
可以啊，好吧。对啊，我应该给你们看这个比较好。OK，你看哦，你看 y 等于 x square 是这个 ，OK，所以你要看全部人 approach 它，意思说你要看，又来，算了，可能太那个了，太复杂了，做得出。你看，全部人 approach 这一条线的时候啊，全部都在靠近1/2。如果你可以看，你看有吗？你看1/2在那边嘛？ 所以全部的 approach
去零呗。
下去里面
哎，其实不是的，它这个可以无限进、无限进、无限进，它没有下来。其实它这个只是一个补充，你懂什么意思吗？它只是填颜色的吧？它其实电竞无限进的，就是你看啊，就是这一圈东西，不是它是无限进到这个00点，所以你就算看到这个00点被 fill out 啊，它没有 fill out 了，它 fill 不到了。我们讲它 undefined 嘛，所以它这个东西是一直靠近，所以你可以放空白在这边啦，其实懂意思吗？就是你也可以放空白在这一面，它就是这样一直靠近，只是它放了一片颜色进去，懂什么意思？
就它这里不会弯下来，
不会弯下来，不会弯下来，它就是这样吧，它就是这样吧，一直 approach 这样，一直
就是用1/2的方式来靠近你。
啊，就是这整个 shape 就一直靠近嘛。其实它这边应该不该 fill up 的，这边也不用 fill up，但是它 fill 一下就感觉给你看一个 surface 的。
还是整个东西在 approach，那个地方，所以它没有一个新的 point 上面的。
对，你看它这边 approach 1/2，但是你这边又是0，所以去这个点我到底是要1/2啊，还是要放0呢？对，你明白吗？所以中间这边是空的，其实它放这个啊，它只是把它变到美一点，让它 continuous。
从来一个但是是小多这一点，不过基本上是什么方别人是我我想问的是，一整个拼吧，不止两个，再放进去，再一整个那个或是那个，
然后
或两个，如果是一个 plane approaching 那个 point instead of，如果这个 plane approaching wider than x 零的话，这样它不会有 limit 啊。
这种什么叫一个 plane approaching？你要讲什么？
我是讲，如果
你要讲什么？你想一下，你想一下，你再想一下，可能要开始了，怕等下来不及。你再想一下，你要再跟我知道。Testing. Wait. Okay. Right. So let's start. So please check. If you think that if you worth more marks, you just come to me because I only mark question 2. For the rest, I'm not sure. It's marked by the other lecturer. So if you think you have more marks, you just come approach me. Later. After discussion. Okay. So take a photo before you return to the return me the physical at the end of the class. Huh? What? Yeah. Okay. So first question. Later I will post also, but if you want to take photo first also can. I'll post with lecture notes also. I'll post with lecture notes. Okay, first question. So first questions use a parametric curve. Okay, give you a parametric curve. Instead of normal y equals to cos t, right? Here put y equals to 1 minus cos t. So how you create sine and cos? You just move the 1 to the other side. Okay, sorry. Okay, you just move 1 to the other side. You can see that x squared plus y minus 1 squared is just equals to 1. Okay, using trivial property. If you cannot see this, you want to be classical. Okay, you sub some xy value, maybe also work. Okay, but if you can use the point plotting to find your curve. Integrate with an arrow of the direction in which curve is traced. Okay, so this depends on the interval we gave. Okay, Because there's a direction on the interval from 0 to 2 pi. This picture here has nothing to do with this question. Okay. So you can really see that this is a circle, shifted circle with a center 0 and 1 with radius 1. Okay. This question should be relatively easier. So the direction of the curve depends on the interval we give, 0 to 2 pi. Okay, second question here. Find the area of polar graph. Okay. You don't need to care about the how you sketch it. You just need to find the intersection and decide how to find the area. Okay. Actually, sines and cos are shift of each other. So the way that the curve is the same. So you can really break this intersection here into how many parts? 16 parts. Yeah, if you like. 16 parts. So originally you have 1, 2, 3, 4, 5, 6, 7. Okay. And then the third question here, find the equation of plane that passes through a point and perpendicular to the line. Okay, so what's this question asking? So you already given a point, okay, and then you given a line, okay, but this line is in a parametric form, okay. So you need to get direction vector from this parametric form, right? So you know how to get the direction vector or not? No. So this line is a line with intersection 0, 2, 3 plus the directional vector 3 minus 1, 4. Okay. So this part here is your direction vector. Okay. So you are given that the plane is perpendicular to this direction vector, meaning that this direction vector is a normal vector to the plane. So you got a normal vector, you got a point, you just combine them using the plane equation. Okay. But okay. Okay. Number 4. Number 4 is the question we have quiz inside our quiz, right? Find a length of the curve. Okay, I give you parametric equation, and I ask you to find the length. Okay, so you need to compute dx dt, dy dt. Okay, take the square, add them out, take the square root. Okay, and then integrate over the interval. Okay, this is a question appears in our quiz. Similar question. Okay. Yeah. Okay, so far any question on, you want to repeat anything on question 1? No, okay, so far okay. So you check if you have extra point to add, later you can claim for me. Okay, question 2 marks by me, so I can give more detailed analysis here. So question 2, find the first question is find the slope of tangent line to the given polar curve at the point. Okay, so this is the revision question I gave, if you remember. Okay, is it? Okay, next one is, but this one is not. So this one is just compute dy dx at the point theta equals to pi. So a lot of you compute the differential wrong. Okay. Second, some of you substitute it wrong. Okay. Yeah. Most mistake appears here. Question 2, find the tangent line. This is what we discussed in the class. So you need to find horizontal tangent line. You need to make sure dy d theta is 0, but dx d theta is not 0. Okay. So a lot of you didn't check ds theta not 0. Okay. So I give 2 marks as long as you can write xy in terms of theta and r, and then give 2 marks if you can compute the dy d theta or dx dy dx. Okay, for both these questions, and then I give you 1 mark to compute the right number. For question 2, right? I give extra mark 1 mark if you not extra 1 mark, but the last mark of the 5 mark I give to checking dx d theta is not 0. Okay. Okay, question 3. So question 3 here, right? There's some details is not given, but actually what I want in this question is move from the point from P to Q in a straight line with constant velocity from 0 to 1. Okay. Otherwise, you can really reparameterize your time. Okay. But if you don't do it, it's fine. As long as you give the basic answer, it's fine. Okay. So find the vector equation and parametric equation for the line segment traveled by the particle. Okay. I think quite a lot of you can do this. What you don't do is you don't give the interval. You just give me the equation. Okay. If you don't give me the interval, you give me the equation, right? That line here, the line here, right, will extend forever. Okay, which is not I want. I just want segment. Okay. Start at P, end at Q. Okay. If you don't give me the time, then this line will extend forever. And then find the velocity of this particle. Okay. So how to find velocity? You just take the derivative of your displacement. Okay. So in this case, we have 3-dimensional. You need to take derivative at each dimension. So you are differentiating a vector function. You are differentiating a vector function. And then the next part, I ask you to find the speed. Okay. To find the speed, you compute the length of your velocity. Okay. One is scalar, one is vector. So you need to differentiate between these two quantities. Okay. One is vector, one is scalar. Okay. So one is a constant vector, the other is the scalar. Okay, so far so good. Yeah. Okay, next question. Find a vector function that represents the curve intersection of two surfaces, x squared plus y squared equals 4, and the surface z equals to xy. Okay, I thought this one is a hard question. Apparently, you guys can play around with it and then at least come up with some number, some value. Okay, so this question here, you need to find a curve, right? So you need to find a parametric curve that satisfies both equations. Okay, you know how to find the parametric curve for a circle, and the z value is controlled by the coordinate of the circle. What you don't do is you don't give the interval also. Okay, you don't give the interval. If you don't give the interval, right, meaning you are keep looping around, doing it forever. Okay, but now I just want a circle, a curve. Okay, if you don't give the interval, then the circle will keep looping itself. Okay. So you know what is this surface, this curve looks like? You have a cylinder, okay, and then you have a plane intersecting. So you get something in the middle here. Okay. Yeah, you take the intersection. Okay. So let's keep going. Okay, so question 3, there are some convergence of series. It doesn't necessarily that you follow this method, as long as you produce a method that compute the right things and the right step should be fine. Okay, so first step here, the suggested solution is to use comparison test. So comparison to what? Comparison to geometric series 1/3 to the power n. Okay. B. So you already see alternating what? Alternating alternating series tests, right? Then maybe one possible way is to use alternating series test, but here we can use ratio tests. Okay. Like what I say, right? First thing you can try ratio test, easiest one. You can try ratio test. C. C here also can work if you use ratio tests. Okay. But make sure you compute the right limit. D. So D is not convergent by using the divergent test. Okay, if you compute the divergent test, you will get equals to 1. Remember how to see this question here? Last time we see that the polynomial can be estimated by the highest degree. Okay, so the highest degree at the top is n squared, bottom is also n squared. So you might think that the limit will approach 1. Okay, but if you compute it, you also approach 1. So by divergent test, it is divergent. Okay, so question 4 here. It says that use integral test, but a lot of you didn't check whether it's continuous, positive, or decreasing. Okay, even if you don't do that, the lecturer said just give you 5 marks. Otherwise, too many people lose marks. So in principle, you need to check continuous, positive, and decreasing before you use integral test. Okay, or at least you mention, right? So I think the integral is not too hard, right? Okay. So part B, interval of convergence. Okay, interval of convergence. So you use ratio test again. So many ratio tests. You can use ratio test, and then you need to check the endpoint. Okay. So this is the skill you need. Yep. Let me see. Interval. The question is about interval. If you didn't or did check endpoint, then you won't. Yeah. Because you haven't answered the question. Yeah. Yeah, you answer half. So half is 6 mark here. So make sure you get 6. Yeah, make sure you get 6. So half is 6 mark here. And C, use the Taylor expansion formula to find the first 4 non-zero terms. So you just need to compute up to first 4. Okay. Center at A equals to 1. So you substitute your center as 1. Okay, so it's quite pleasing that some of you improve from your quiz mark. And then I'm not sure why some of you drop in your result. So for those who get distinction, we have Liang Jiayu, Fang Zitao, not here, is it? Gao Qixiao, Jiang Hongyu, Li Yuzhang. Who is Li Yuzhang? Okay. And then Tian Yang, and then Ling Po, Long Ling Po also get distinction. 金花，and then 宋子飞会宋子飞，okay good 子飞，and then 张云here not here， 张云 not here， 赵静航 ，okay 赵静航 good， Yisun, so Yisun got highest of 99. The 1 mark is I take off one. Okay. No, it's okay, it's okay. Still have room for you. Good, good. To Seng. Seng, good. Puntat. Also Renis, good. Qingrou also got distinction. And then last one, Wu Chengze here, no? Not here, Wu Chengze. No, okay. Right. So if you have a question on mark, you can come and claim with me. If not, you return the test paper back here. Yeah. Here TB, okay, Ken. So question 2B, when we finish this question 2B. Question 2B is what?
我觉得我
Yeah, question 2B, yeah. So
今天挑一个里面，
你要看还是要我解释？你要看还是要我解释？你要看 ，OK， 给你看。
老师签到
我自己会签，我不会签。
不会签，那什么？
那
那你怎么通过什么方式知道我们到没到？
我通过谁没拿，我就知道谁。
哦，谁没拿 ？OK， 那现在就如果没什么事就可以走。
没有事就可以走了。
OK，
也是拜拜。Thursday, see you on Thursday。再见。
这是第4题。
第4题 B 哈。check 一下啊。这样对吧？对啊，就说。
把那 x 放过去了，可是我找的是一样的答案呢。因为我讲这边是。
可是你我
没有
做几分先？
不完。
我明白了，
不能啊，这个这样子不能吗？
哇，感觉。